Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So today we'll be solving the problem clone a linked list with random and next pointer. Before starting off with the problem, if you guys are new to our channel, please do check out our other videos and please do support by subscribing to the channel. So yeah, let's get started with the problem. So the problem states that you'll be given a linked list such that there is an additional pointer. Now every linked list that you would have seen till now has a next pointer, but over here we have a next pointer. Along with that, we'll have an additional random pointer added to it. Now the question states to return a deep copy of the linked list. So let's understand the question properly. Imagine this is the linked list which is given to you. So generally we see that the white colored linked list is the one which we have been dealing with till now. But over here we have added one more pointer to it. See, we have the value. Over here we have the next pointer pointing to the next, but we have one more pointer. Yes, the random pointer. Now this random pointer can point to anyone. Yes, can point to anyone. Like over here you can see that the random pointer is pointing to the null. For the second node, the random pointer is pointing to the first node. For the third guy, the random pointer is pointing to the last node. For the fourth guy, the random pointer is actually pointing to the node which has 11. While for the fifth node, the random pointer is pointing to the first node. Now your task is to exactly return the same linked list. Yes, but not this one. You have to create one more linked list which is exactly the same, which should have exactly the same next pointers as well as the same random pointers, and you need to return it. Since I'll be explaining you the approach to the given problem, let's take a smaller linked list such that it doesn't becomes clumsier while explaining. So if you are in an interview, the first solution that you're going to tell to the interviewer should be the brute force one, where we are going to use extra space complexity. So at the first step, we are going to create an hash map, which is going to store a node comma node. That means for every node, I'm going to represent it by another node. So initially what we will do is we will traverse in the given linked list. So first, when we reach over here, we are at this node. So for this node, we create one more node similar where we assign the value 1. But remember one thing, you are not going to assign any next and random pointers. And you are going to do one more thing. For this node, you're going to say that you have created this corresponding node. So if someone comes up and says you, what's the copy of this node? You can easily extract via the hash map that the copy of this node is this. Right after that, you move the pointer to this. From here, it's going to move to here. So after this, you're going to create a copy of this one. Now, since you have created one more copy, you're again going to keep it in the hash map saying that for this 2, you have created another copy. Basically, these are different addresses, so they will be represented differently. So again, if someone comes up and says you, what is the deep copy of this node? You can easily say that the deep copy of this node is this node using this hash map. Similarly, we are going to do for this node. We're going to create one more. And after creating, we are going to store it in the hash map. Right after this, our pointer will move over here. And for this guy, this is going to be 4. For this guy, we are going to create one more deep copy. Now remember one thing, we are going to create deep copy, basically the similar copy of nodes, and we are going to keep node comma node so that for every original node, we can know which one is its deep copy. Now once you have done this, the next step is very easy. Now what you're going to do is you're going to traverse again on the original linked list. Now over here, you are at 1. So what you're going to do is, for 1, you see what is its next pointer pointing to. So you see that one's next pointer is pointing to the node which is having 2. So you can say that one's deep copy is going to point its next pointer to the deep copy of this node. So you can easily point it to 2. So the next pointer gets easily pointed. Now if you want to know one's random pointer is actually pointing to the node which is having a value 4. So its deep copy is this one. So you can easily say that the random pointer is going to point to this. That's going to be very easy. So if you know this guy is random. You can easily point this guy as random too, because this guy's random is going to point to deep copy of this guy's random. Simple as that. Once you have done that, you move to the next guy. That's this one. So again, you can see that the next pointer is pointing to 3. So who is its deep copy? 2. So its next is going to point to the deep copy of the next which the original is pointing to. Right after this, where is the random pointer of 2 pointing? It's pointing to 1. So the deep copy of 2, its random is going to point to the deep copy of the node 1. That's 1. So again you point this. So the random pointer easily gets generated. And how do you get to know who's the deep copy of 1? Again, using hash map, you can easily get who's the deep copy of this. After that, we are going to move this to this node. Now we are the third node. Now at the third node, you again see who's the next pointing to. So the third node's next is pointing to 4. So what we are going to do is, its deep copy that you can easily get using hash map, that is this, its next will be pointing to the deep copy of the node 4. So that's done. Now who is the random pointer pointing to? Null. Now if it's pointing to null, you're not going to find any deep copy and you're going to simply point it to null. So you've pointed it to null. Right after this, we move to the next guy, that's the node 4. Now at node 4, we see that the next pointer is pointing to null. Now whenever it's pointing to null, no need to find its deep copy. Directly point it to null. Again we see that the random pointer is pointing to the node which is having a value 2. So we find the deep copy of the node 2, that is this, using this hash map. And we say that the random of the 4 is going to point to the deep copy of this original node, that's this. So we can see that after completing the iteration, we reach null. And that is when we can say that we got our deep copy. And how do you get that head of this deep copy linked list? You can easily access it. The answer is very easy. Whatever is the original head, the deep copy of this guy will be the original head of your deep copy linked list. So this is how you're going to get your answer. So if I talk about the time complexity, it's going to be a big O of n for the first traversal when you create these nodes and insert them into dummy nodes. I'm assuming that the hash node is working in big O of n. And right after that, you're going to use another big O of n while you again traverse and point the next n random pointers. And the space complexity used is going to be big O of n, which is going to be for the hash map that you're using. So when you propose this solution to the interviewer will not be happy with the extra space that is big O of n, the hash map that you're using, and he'll ask you to optimize this. So let's understand the optimized solution in our next step. Before moving to the next part of the video, I'd like to introduce you to all the free classes that Unacademy is organizing for the people who have just started programming or are intermediate level or are at advanced level. So you can check out all the beginner classes. Now all these classes, yes, all these classes are free and they're not charging you anything. And these classes are taken by top-notch instructors. And if you're someone who's an intermediate, then you can also check out the videos like trees, segment trees, game theory, dynamic programming, string hashing, square root decomposition, queries on trees, DFS and BFS, and the other videos. Now again, these videos are free. Again, if you're someone who is at the advanced level, you are also getting free classes like persistent data structures, linear algebra, byte connectivity, suffix arrays, centroid decomposition, introduction to flows, then FFT, then persistent centroid decomposition. Now everything is free. So please do go check it out. If you are a beginner, if you are an intermediate, if you are an advanced guy, do check out all these free classes. Just in case at any junction you need a code to watch these classes, just insert the code, take you forward, and you'll be able to watch all these free classes. After watching all the free classes, if by any chance you feel like taking up the subscription, you can check out all their subscription plans that they are giving. And if you want to enroll, you can use the coupon code take you forward. You will get an additional 10% discount. And I'll also add that I'm not pushing anyone to take up the subscription. I'm promoting the free classes. Everything apart from that depends on you. So the optimized solution will have 3 steps. I'm going to explain you all the 3 steps part by part along with the pseudocode. So let's get started with the first step. So the first step of the algorithm is very simple. What we are going to do is we are going to create copy nodes. Yes, we are going to create copy nodes of the node like 1, 2, 3, 4, and we're going to insert them right after the original nodes. Something like this. As of now, 1 is pointing to 2. So what we are going to do is we are going to create the copy of node 1. So let's call it 1 dash so that you don't get confused. Yes, the number will be 1, but I'm just assigning it with 1 dash in this diagram so that you don't get confused. Now, the next, instead of pointing to 2, this will get cut, and once next is going to point to 1 dash, and the next of 1 dash is going to point to 2. Basically, I inserted the copy node right after the original node. After that, we're going to create a copy node of the node 2. So we create a copy node of node 2. Again, I'm going to call it 2 dash. And right after that, we are going to break this link. And this link is going to point to this. And this guy's next is going to point to 3. Next, we go to the node 3. And similarly, we are going to create a copy node 3 dash. And we're going to break this link. And this next is now going to point to 3 dash. And 3 dash next is going to point to 4. After this, we are going to create a copy node for the node 4. That's going to be 4 dash. Now, the next of 4 is going to point to 4 dash. And the next of 4 dash is going to point to null. So you can see that I inserted the copy node right after the original node. Now you can see something. This blue nodes are your deep copy nodes. Now they have their next pointers. But the problem that we were facing was to point the random pointers. Because whenever we create these nodes, we don't know where the random pointers are. Because when this node is created, the random pointer to which one is pointing is the node 4. So the deep copy node 4 was not created at that time. That is why we could not point the random to the deep copy node 4. So now how are we going to do that? So now is the step 2 that we are going to do. So in the step 2, we are going to point the random pointers. So let's see how we are going to point the random pointers in our step 2. So what we are going to do is we can say that we start with a variable iter. That's a pointer which is pointing to the head of the linked list. So that's pointing to 1. So we can say that the iter's random pointer is pointing to the node 4. So can I say iter's next? So iter's next is the deep copy. Actually, that guy is random. That means I'm saying that guy is random now. Is gonna point to, what if I say iter's random is this node 4 and the next of that, because I for sure know that whatever is the random pointing to, the next of that is the deep copy. So I can easily say current iter's random dot next is my deep copy of this node 4. So easily this guy goes and points to the node 4. So I am successfully able to point the random pointer of our deep copy node. So after this, what we do is we say iter to move by 2 steps. That is iter's next dot next. So in the next step, iter is going to reach over here. So again in the next step, if we perform this iteration saying that iter's next random is gonna point to this guy's random next, that's this. So this is simply going to point to this. So I'm able to point the random pointer of the 2 to 1. After that, again I move iter by 2 steps. Why am I moving by 2 steps? Because I don't want to go through the deep copy nodes. Now we are at the third node. Again, we can do the same thing. We can see that 3 is pointing to null. Now, whenever it is pointing to null, what you can do is you can simply point the next to null. You don't have to do anything else. That's an easy step. Again, at the next step, we are going to go to node 4. And we see that the random is actually pointing to the node 2. So again, we go to iter's next random. So iter's next random is going to point to iter's random. That's 2. Its next. That's 2. So we have pointed this. So our linked list is having changed something like this after the step 2. So the last step, that is the step 3's, its motive is to get the original linked list back as well as get this deep copy linked list back. Now if you carefully observe, the deep copy linked list is this blue guy, and this blue guy's next is pointing to 2. Instead of that, if I am able to by anyhow make this next pointer pointing to 2 dash, 2 dashes next pointer are pointing to 3 dash, 3 dashes next pointer pointing to 4 dash, I think my job will be done. And 1's next pointing to 2, 2's next pointing to 3, 3's next pointing to 4. If I'm able to do this, I think my job is done. So what we can do is, we can take variables. Yes, we can take dummy variables. So let's take a dummy node which is assigned to 0, and let's take one variable iter. That's a pointer, you can say. After this, at the first step, what we always do is, wherever iter is standing, make sure you stand front, variable front, at 2 steps ahead, that is iter.next.next. So as of now, iter is standing over here and front is standing over here. Now, first time, create the deep copy linked list. So for that, at the first step, make sure the next of the dummy is pointing over here. So once you have done that, at the next step, break this link. Basically, you're saying that once next is now no more pointing to 1 dash, and that's going to point to 2. So you are able to successfully create the original linked list back, at least for the first step, that is create this. Because you know one thing, the random pointers are not distorted. The next pointer was distorted. So you have done this. So once you have done this, move to the next step, where you move iter to directly the next, that is to 2. And at every junction, what you do is, you move front to its next. So front is gonna stand over here. Now iter's next is pointing to 2 dash. Now you were having a point over here, if you remember. That's at 1 dash. Because initially you took that dummy node, that pointer was standing over here. So that next points to 1 dash, so you will move the point over here. Now what you can do is, you can say, this guy's next is gonna point to iter's next, that is 2 dash. So see, actually at the top guy, you're creating something that a dummy node, and that's next is pointing to this deep copy node, and again you're creating this guy 2 dash. So we have created that. After that, you can again break this link and make sure this link is established. So we have got this original linked list back in order now. So once you have done this, again, just move this pointer at the 2 dash. Once you have done, you can move iter to front, and after that front will move to the next. So front is over here. So again, you can say this guy's next is gonna point to iter's next, that is 3 dash. So this is now pointing to something which is 3 dash. So we are able to create our deep copy node if you are carefully observing. After that, you just break it and say this node is established. So the node with 4 is established. Right after that, again move iter over here and front over here. Now once you have done this, make sure you move this to that 3 dash. So once this is moved to 3 dash, you can say its next is going to point to iter's next, that is 4 dash. So you are able to successfully create the deep copy node if you carefully observe. So we see we have created the original linked list as well as the deep copy linked list. You can do it till null and you'll get this as null and this as null. And the random pointers stay as it is. The green lines and the orange lines stay as it is because I've successfully able to create it. So we can see that at step 1, we created the dummy nodes that are the deep copy nodes. At the step 2, we made sure that these green lines, that the random nodes are connected. At the step 3, I made sure that the next nodes are connected, and I got my deep copy linked list as my answer. So if you analyze the time complexity of every step, so I can say at the first step, I created all the nodes. So that's going to take big O of n for step 1. After that, I can say again assign all the random pointers. So that's going to take a big O of n extra. After that, again, I can say I made sure that I segregated the original linked list and the deep copy linked list. So that's going to take another big O of n. So I can say that's near about big O of 3n, which I can say equivalent to big O of n, which is linear in nature. And if we talk about the space complexity, we are not using any extra space complexity apart from the one we are creating the deep copy linked list. Now that's allowed, but we are not using anything extra like hash map or something like that. So we made sure that the space complexity of hash map that we were using, that was gone. So this is the most optimized solution that you can get for this problem. So now it's time to discuss the C++ as well as the Java solution to the problem. Generally in linked list, the C++ and the Java solution looks similar. So I'm going to only be discussing the pseudocode. Yes, I'm going to be discussing the pseudocode for this problem. You can find the C++ as well as the Java solution links in the first pinned comment. So I'm going to discuss it step by step. So if you remember, we did a step 1 at first, then we did a step 2, then we did a step 3. So let's get started with all these steps. So let's see the pseudocode for the step 1. So the pseudocode for the first step is very simple. What we do is initialize iter as well as a variable front. So these are two dummy nodes created and both of them will be initialized to head. Now head is nothing but the initial node, that is the node 1. After this, what we are going to do is we are going to iterate iter. Yes, iter is initially standing at head, so we are going to iterate iter till it doesn't reaches null. After this, we are going to say front to move to iter.next. Now initially the link was this white link, so front is going to move over here and the iter as of now is staying over here. After this, we create a copy node. Now in this copy node, what we are going to do is we are going to initialize a new node with a value similar to this. Basically, we are creating a deep copy of the node which is having the value 1. So iter was the node which was representing the value 1. So I created a deep copy of that node. Now it's very simple. Iter's next should point to this node. Now this node can be called as your copy node as of now. So let's point that. So iter's next now simply points to the copy node. So we have done that. After that, we can say copies next is going to point to front. So let's do that. So copies next is going to point to front. Okay, we have done that. Now for the next time when you come back and you do create a similar stuff, obviously the iter has to go over here so that again front moves ahead after that copy gets over here. So we can do this is we can move iter to front in the next step. So obviously our iter will go over here and at the next step when it comes, front again goes over here, then again we create a copy, then iter's next goes over here. So this thing will go on till your iter doesn't reaches this guy, and right after this doesn't reaches null. So this is how you're going to complete your step 1's code. So the step 1's code is ready. Now let's deep dive and check in the step 2 code. So if you remember the logic for the step 2, it was very easy. What we did was we pointed the random pointers of the deep copy nodes. And for that, we initially started with something as iter initially pointing to head. And we kept on moving that iter till it did not reach the end, that is the null. So let's move it till it doesn't reaches null. And after that, we can say if iter's random pointer is not pointing to null, we can write the statement that I wrote while explaining you. That's iter's next dot random, that's the deep copy node, is gonna point to the current random of iter, and you know who's the deep copy of that, that's the next. So we simply point it, and after pointing this, we know iter's gonna move from here to here. That's 2 steps because the links go via this. So that's going to be iter dot next. So this is how the code for the part 2 is going to look like. So the code for the step 3, where we differentiate the original list as well as the deep copy list will look something like this. Initially, we start with this iter, where we point this iter to head, because if you remember, iter was initially pointing to the head. And after that, we create a dummy node. Yes, we create a dummy node, and this dummy node can be called as a pseudo head. And this pseudo head is a dummy node having a value 0. And we can create a copy node so that we don't lose a track of the initial head of the deep copy list. And this copy is initialized to pseudo head itself. So copy and pseudocode both are standing at the dummy node, and the iter is standing at the first guy. So let's see how are we going to extract this. At the first step, we can say, we know iter is going to move till it doesn't reach its null. So let's simply move it till it doesn't reach its null. So iter as of now is standing over here. Until it doesn't reach its null, it's going to move. Right after this, if you remember, we were assigning front to the next guy. So how will you get the next guy? Now these links have not been broken. So I can say iters next. Next is the front. So front can be easily called as iters next dot next. After this, let's extract the deep copy list. So can I say copies next, that is this dummies guy, next will be pointing to iters next. So simply point copies next to iters next. So once this link has been established, so you have this deep copy with you. I don't need this link. So once this is done, you have got your deep copy list. So you don't need this link. So what you can say is, now iter dot next will be pointing to front. So what you did was you broke this link and you made sure this link was pointing. Now at the next step, make sure you move this pointer over here. So you can simply say, now copy will move to copies next. So it moves over here. Now this is the reason I took two variables, such that the pseudocode still stands at the dummy node. So once you have done this, you have moved copy. What is your next step? You have to move iter from here to here. So you simply call iter equal to iter dot next. And this is how this is going to move to next. And again, the same thing will happen. Again, it comes back. Front will go to iter dot next dot next. That is this guy. Then copies next is going to point to iters next. So copy is standing here. Its next is going to point simply to this node. After that, you say iters next to front. That says this. After that, you say copy to copy dot next. That is, you move from here to here. And again, after that, you move iter to here. So this keeps on going, and ultimately you get your original linked list as well as your deep copy linked list. Both of the linked lists are ready. But what is the head of your original linked list? So this is your original linked list, this blue one. But this is the dummy node, that is the pseudo head. So I can say pseudo heads next. Pseudo heads next is going to be my head of the deep copy linked list, which is what I'm going to return as my deep copy linked list head. So this is going to be my code for the C++ as well as the Java solution. So guys, I hope you understood the entire explanation of the problem. Just in case you did, please make sure you like this video. And if you're new to our channel, please do not forget to subscribe to this channel. And yes, don't forget to hit that bell icon, because that notifies you whenever I post. With this, I'll be wrapping up this video. Let's meet in the next video, where we will be solving the next problem from the SD sheet.